hear, and learn. Welcome to the future. A very good morning to all present today. Respected speakers of the day, Dr. Shilpa Bhaskaran and Ms. Suma Ellis, Principal of UC College, Dr. David Such Matthew, sir, other faculty members, and dear participants. I welcome you all wholeheartedly to a two-day webinar on machine learning for biology. As someone once said, a baby learns to crawl, walk, and then run. We are in the crawling stage when it comes to applying machine learning. We, the Department of Biosciences of Union Christian College, Alua, are here to conduct a two-day webinar on machine learning, and we have two amazing resource persons with us. Dr. Shilpa Bhaskaran is a research associate at Department of Computational Biology and Bioinformatics, University of Kerala. Dr. Bhaskaran also served as the editorial assistant in the International Journal of Computational Biology. She did her MSc in Computational Biology and PhD in Bioinformatics. Welcome, ma'am. We also have Ms. Suma Ellis, Assistant Professor at IHRD. She has 15 years of teaching experience and currently takes computer science related classes at DCB. She did her MTech in Computer Science and Engineering, and her current research focuses on optimization algorithm for drug design and synergism. So without further delay, we move on to the formal inaugural session. I invite Mr. Shyam Mohan, HOD Biosciences Department, UC College, for the welcome note. Please, sir.
Good morning, everybody. And today is indeed a wonderful day because we first time got the opportunity to have a topic, a discourse on machine learning. So this particular topic, as earlier Anjali had mentioned, has significant role in the coming years. We can see how artificial intelligence and data analysis are shaping the world around. So the impact of these subjects have its own effect on biology as well. So being students of bioinformatics and being students from the biological sciences domain, it would be imperative that we have the fundamental knowledge of how machine learning operates in biology. So I think this would be the right kind of platform where the students have the initial idea of what machine learning is and what artificial intelligence is, and all associated topics along with that, the support vector machines, the artificial neural network, etc. So we are fortunate enough to have the speakers of the day as well. So my job here is to welcome all of you to this program. So without much delay, I will start my proceedings. Firstly, I would like to welcome Dr. David Such Matthew for inaugurating this function. Sir is a principal of this college, and Sir has been associated with our bioinformatics department. In fact, from its inception, Sir was instrumental in the development of the course in the college. So he has also been witnessing the developments that are coming in the college. So regarding bioinformatics and how the subject has evolved. So it is nice to have you here, and it would be good that Dr. David Such Matthew would be the right person to inaugurate this discourse here. So I welcome Dr. David Such Matthew, sir, to this program.
Thank you.
Secondly, I would like to welcome the resource person for the day. Initially, I think it is Dr. Shilpa Bhaskaran. She has also been a close associate of us in our department. I think she has formally been associated with Bibin sir and so it's our pleasure to have you here, madam. And I think you have a very fruitful session in attending our webinar today, and hope you have a nice time here. I welcome Dr. Shilpa to this program.
Hey, thank you, sir. Thank you so much.
Okay, next I would like to welcome Ms. Suma, who's an associate professor in the IHRD college. Ms. Suma ma'am is also, all of them are close friends of teachers of our department. It's our pleasure to have Dr. Suma ma'am also in this program, where ma'am can, in the second session, ma'am also will handle topics in machine learning. So Suma ma'am, I welcome you to this function.
Thank you, sir. Thank you.
Next, I would like to welcome Vipin sir to this function. Mr. Vipin Thomas. Sir has been the role model for our students, and sir has been running this program. Actually, he has taken the efforts to gather the momentum for this conducting the webinar on machine learning. So, Vipin sir, without much formalities, I welcome you to this program, sir.
Thank you, sir. Thank you.
Next, next, I would like to welcome the students of the bioinformatics department, the students of the MSc Bioinformatics part of the biosciences department, because this program is kind of exclusively a subject that is associated with bioinformatics. So the initiative and the coordinating help that Vipin sir needs was provided by the students of MSc Bioinformatics. So firstly, I would like to welcome the students of MSc Bioinformatics, third semester. I would also like to welcome the students of Biosciences Department, students from MSc Biotechnology and BT&SP, who have tried to understand and know what these subjects are. So being the time of various seminars that are running all throughout, this one seemed different to them. And I can understand that their curiosity in learning machine learning. So this would be the right kind of stage for them to understand the basics of machine learning, especially because so much of propaganda has been there regarding artificial intelligence and machine learning. They are interested and curious to know how biology has been associated with these subjects. So welcome to all the students and those participants from outside our college and students from the bioscience department. I would also like to welcome all the faculty of our college and especially bioscience department, all the teachers who have been, we have been organizing programs consistently for the last few days, and all over this month we have some more programs in our kit. So the teachers have been motivational and inspirational to the students as well. So I welcome all the teachers of the bioscience department and teachers of UC College. And a last word of mention to the non-teaching staff of our department as well. So I welcome all of you to this program. Hope you have a wonderful day. Thank you.
Thank you for that warm welcome, sir. Next, I invite Dr. David Sech Matthew, sir, Principal, Union Christian College, for the inaugural address. Sir, please.
Thank you. Thank you very much. Respected head of the department, Shyam Mohan. Today's special invited speakers, Dr. Shilpa Bhaskaran and this is Suma Ellis. Mr. Vipin Thomas, faculty, who is working behind this seminar, and other faculty members, non-teaching staff, and my dear students who are participating in this seminar. Of course, our college is doing well in this pandemic period, particularly in the webinar organizing. There is a healthy competition, I think, is going on. Every department is making use of this pandemic time, particularly for making such seminars and webinars and this intellectual discourses, intellectual activities. So today, as Shyam Mohan already mentioned, I was very much associated with this bioinformatics course because I was the course coordinator for 10 years for this bioinformatics course. And as the the person who introduced this seminar, we are in a way, still we are in a crawling or not in a running mode. We are at the cradle, still we are in the cradle in this particular subject. Anyway, there are a lot of changes or a lot of inventions are taking place in this subject, and particularly this artificial intelligence, machine learning, and many other subjects which are related to bioscience as well as bioinformatics are coming up. And I think this particular situation, this pandemic situation, make this process little more faster. And I think within no time we will come to the reality that things are which once it was in the comic books or even in the science fictions. Now it is going to be a reality in front of us within no time. That is that much faster this particular subject is going on, or work is going on in this science, particularly in bioinformatics. So this seminar, so these 2-day seminars, 2-day webinar is going to be really a good fortune for bioinformatics students, particularly, as well as to other bioscience students, to understand what is happening around us and what is going to be taken place in the future. So with a hearty welcome from my side, I'm using this opportunity to welcome Dr. Shilpa Bhaskaran as well as Mrs. Suma Ellis to Union Christian College for this particular webinar, as well as to Union Christian College. So this is this opportunity. This time I wish to thank and congratulate each and every person worked behind this seminar organizing to make this a good success. It is going to be a good successful seminar, no doubt about that. And wishing all the best for the participants, and make use of this time, as well as this experts to understand what is what is machine learning, as well as in the omic terminologies and omic science, which is going to be happening, and which is going to be coming into force in the future. So thank you very much, and giving me this opportunity to speak few words to you, and all the best for this seminar. Thank you once again. Thank you.
Thank you so much, sir. Now, I invite Mr. Vipin Thomas, Assistant Professor of Bioinformatics, to conclude our formal session with the vote of thanks. Over to you, sir.
Thank you, Anjali. Good morning, all. As most of us know, machine learning is a technology of future, and it has revolutionized many areas like customer analysis, weather prediction, and many fields in biology. So, machine learning techniques like random forest, HLMs, SVMs, genetic algorithms has been used in biology for areas like gene prediction, genome annotation, protein structure prediction, and there are many machine learning algorithms are being used in pharmacological research, including target identification, active ingredient prediction, toxicology prediction, pharmacokinetic activity prediction, and so on. So with the advent of technologies which enable us to produce a lot of data, these techniques allow us to find out patterns and information from huge volume of data, which is otherwise incomprehensible to the human mind. So I think that this machine learning webinar will enable the participants to get a basic idea about the topic, as well as generate interest in them. So I thank Dr. David Sasser for the support and finding time to be here for his busy schedule. I would like to also thank Dr. Shilpa Bhaskaran and Suma Miss for being a part of the event and accepting our invitation to be the resource person for this webinar. And then I would like to thank Shyam and my fellow faculties in the department for their support in the data. And finally, I'd like to thank my students, especially who are behind this webinar. Anjali, Shreya, others, Reshma, and Joe. And with their support only, we plan this seminar and organize it appropriately. And finally, I thank all the participants and wish that this session will be fruitful to you. And please feel free to interact with the speakers and clear your doubts. And there will be sessions after the talk for interacting with the speaker. Make use of the session and wish you all the best. Thank you.
Thank you so much, sir. So without further ado, let's begin today's event. We have the first session on machine learning for biological data analysis by Dr. Shilpa Bhaskaran. Those who have their doubts and queries, they can be posted in the comment section. We'll have a different question and answer session after the talk. So let's move on to the talk. Over to you, ma'am, please. Hello, Shilpa ma'am. Can you hear me? Hello, ma'am.
Yeah, Anjali.
Okay, carry on, ma'am.
Okay. So I think I am audible. Good morning, dear friends, students, and faculty of UC College Jalwa. I'm so happy to meet you all here. So I'm thanking Mr. Vibin Thomas, Assistant Professor of UC College, for this because through him I got this opportunity to share my knowledge about machine learning here to the students. And I'm so happy that I got some students from biology background because biology for the biology students, machine learning is something computational and which is outside their domain, but this is not the scenario now. So introducing machine learning to biology students from life science background is something which I find as interesting. So, Mr. Vibin Thomas is a person, he's a senior student of the Department of, was the senior student of the Department of Computational Biology and Bioinformatics at University of Kerala when I joined there for my master's program in 2009. Since then, he is my good friend. Uh, uh, and he motivated and guided me, which helped me to me in my professional growth in various aspects. Now I can understand how Anjali and Shreya and other students are benefiting from his guidance and mentoring. So thank you, Mr. Vibin Thomas, and thank you all other students and faculty of UC College. UC College is an institution which is always in close collaboration of close association with our department through the students who are coming for projects. I'm so happy to be here, and let's move on to the session. I think I can share my screen now. Is it working fine, Anjali? Is
Yes,
the
ma'am.
slides visible?
Yes, ma'am.
Okay,
It's
fine.
visible.
So, as you know, today I'm going to talk about machine learning for biological data analysis. And with today's session, my intention is to introduce you to the field of machine learning. I'm covering the basics and the general concepts. And machine learning, as other faculty members were telling during the inaugural session, that you can find as a domain that is in the trend now, as its applications are enabling us to create wonders. So machine learning is a part of your life, I'm sure, knowingly or unknowingly. You all may be the users of smartphones and social media like Facebook. When you put a group photo in Facebook, you can see the Facebook itself tag the names of your friends in the group photo if they are members of the Facebook media. So likewise, if you have a friend who added a group photo in his page, you will get a notification that he or she has added a photo that you might be in.
എന്തോ അവിടാണോ സ്വൈപ്പ്
A
ചെയ്യണ്ടേ?
machine learning program.
അങ്ങോട്ടും ഇങ്ങോട്ടും
There's a
നീക്കത്
machine.
ഇവിടെ കുറെ ടാബ് കണ്ടില്ലേ?
I am listening some other voice also.
I'm sorry, ma'am. Participants, please
Okay.
kindly mute your audio and video so that they don't have any disturbance. Sorry, ma'am.
Okay, it's okay, fine. So there is a machine learning program working behind all these notifications, and you might be using online stores for online purchases, especially during this lockdown period, and you will get recommendation once you buy a product. The recommendations will display like the customers who brought this item has also bought these items, and so sometimes these items that recommended by the online store will be useful for you too. So that is created by a machine learning program, and also the recommendations from Netflix, for watching movies, and the Gmail also. In the Gmail inbox, the mails that are automatically filtered as spam, and without your intervention. And there is a machine learning program running behind these kinds of applications in your day-to-day life. So here is another advanced application of machine learning, which are seen in products like Google Alexa or Echo, or sometimes Google Assistant in your mobile. This Google Alexa is a voice-controlled virtual personal assistant which can detect your voice once you train it, and will perform various tasks for you, like setting alarms for you, updating the traffic, giving updates about the traffic, and controlling even controlling third-party devices in your room, such as television or AC, etc. So another recent application and most amazing application, I can say that it is self-driving cars. You might be reading news and reports about self-driving cars nowadays, or the driverless cars, which doesn't need any human intervention to drive along the road. It will automatically detect the objects, automatically adjust the speed and other mechanisms within the car. And so that is another most advanced application that is yet to launch. I think 2 days to 3 days back, there was also one update about the self-driving cars, that they are going to launch it in roads, try it in roads. So these are all the amazing applications of machine learning and artificial intelligence. When talking about artificial intelligence, you don't need to worry about whether artificial intelligence and machine learning are the same or not. No need to confuse, because artificial intelligence is the bigger domain, and machine learning comes as a subset of this artificial intelligence. And deep learning, which has emerged recently in 2010s, is an advancement of machine learning that I am going to explain in one of my slides. And artificial intelligence, as I said, it's a bigger concept that aims to develop programs that can sense, reason, act, and adapt like humans, while machine learning are actually computer algorithms, and they try to mimic the human brain, and they improve its performance based on the training given to the computer machine. So in today's session, I'm going to cover machine learning only, and I am going to introduce you what is machine learning and how a machine learns, and which are the different types of machine learning. And I'm also going to list out some of the applications in biology as well as bioinformatics. So Emily B. Fox of University of Washington gave a definition to machine learning as: machine learning is a science of getting computers to learn as well as humans do, or better. I took up this definition, even though there are numerous other definitions, because this is the simplest one which explains the matter very clearly. But the most popular definition is given by Tom Michel, a machine learning expert, at US, and he says that machine learning is the study of computer algorithms that allow computer programs to automatically improve through experience. Not that point. It automatically improves through experience. And I suggest you to remind that this is how a human brain does, right? A human brain also learns from its experience, and it makes mistakes, and understanding the mistake, it improves. So we can say that a human brain is actually the motive behind this domain, machine learning and artificial intelligence. So in machine learning, it is actually trying to mimic a human brain, how a human brain learns things from a child, as a child trying to learn to walk, how he learns everything, he or she learns everything in their life as they grow up. The same method or procedure is applied to computers, and that give rise to machine learning. So I suggest I am telling you to recall how you learned things in school. Your teaches you some things, and the teacher, how the teacher is able to understand that whether you have learned it or not. He or she will conduct exams, right? So through teaching and conducting examination, teacher is understanding whether you have learned it or not, and that is how you have learned till it. So after conducting examination, the teacher will give you some marks, and based on the marks, the teacher will come up on the conclusion that whether you have learned it or not. There are some criticism against this, whether the highest mark indicate that that student had learned everything. For the time being, I suggest you to ignore that criticism, and in general sense, highest mark means it indicates you have learned that thing. So teacher teaches and conduct examination to check whether you have learned it, and based on that examination, the teacher will give you mark, and your goal is to increase the mark, as well as the teacher's goal is also to get her students pass with high marks. So the same thing is applied in machine learning. In machine learning also, we have to train the machines. We have to train them, and we have to conduct tests to check whether the training was successful. And after the testing, instead of the marks, here the parameter is accuracy. The machine learning program will give you some accuracy, and based on the accuracy, we have to decide whether the training has to be continued or that machine has learned itself. So our goal there is to increase the accuracy. So this is as simple as how a child learns. In the introduction, Anjali and other staff faculty members were telling this concept, like how a child learns. That is the same thing that we have applied in machine learning also. So now let us take the example of how this baby in your screen learns to identify a dog in his house. So for the time being, let us name this dog as Jack, because we need a label for the data. So this is Jack, and the baby, when he see the Jack for the first time, what things might be noticed by the baby? The black color, of course, maybe 2 eyes or ears, 1 tail, 4 legs. All these features might be there in the mind of the baby, which makes him able to understand or recognize Jack. So as a baby, we always show him Jack, this is Jack, and we continue frequently tell him that this is Jack, this is Jack. So these features might be there in the mind of the baby, and it is quite natural that when he sees some other uh, animal or creature with the same features, as a baby, he might start calling this goat also Jack, right? You can understand the scenario if you have babies in your home. So this is quite natural. So anyway, suppose if there is another dog in the neighborhood of that baby, which is a white Labrador. See, which are the features the baby might have noticed? White color, 2 eyes, 4 legs, and 1 tail. Even though other features are similar, the color is different. So that will enable the baby to learn the difference between Jack and, let us name this white Labrador as Toby. So that is the difference. So a baby learns to understand or recognize between Jack and Toby through these features, like color, eyes, legs, tails. So this is the same thing that we are going to implement in case of machine learning. We have to give the input of Jack, image of Jack, and tell the computer that this is Jack through a computer program. And we have to give that image of Toby and make the machine learns that it is Toby. So for that, we have to give the features in along with the images. That is the input data. So our input data is these images along with these features. These features enable the machine to recognize the particular input data. So the data we gave about the dog is called feature in machine learning also, and the entity that is described by these features is called as label. So note these two keywords, feature and label. When there are more than one input data, it will constitute a matrix like this, and this is called feature vector. So that is feature vector is the input or the specific factor that enables a machine to identify the input data. So in the training phase, you have to give the image along with its feature and the label also to the machine learning program. So this is called the training phase. And the training may not be completed with a one iteration only. Sometimes the training needs multiple iterations, and each iteration is called as epoch. So one epoch means one iteration where the input data is passed into the computer machine, read by the computer program along with the feature and the label. This is what happens in the training phase. And in the testing phase, you have to check whether what learned is totally understood by the computer. That is the aim. So we have to extract a portion of the data that you have used for training, and then you have to input in the second phase. But hello.
ഹലോ ശില്പ കട്ടായി പോയിരുന്നു.
I was muted actually. I got a notification that the host muted me.
ശ്രേയ ഒന്ന് ചെക്ക് ചെയ്യൂ.
Now it's
Sir,
okay. Now I could unmute. എവിടെ വരെ കേട്ടു എന്ന് പറയാൻ പറ്റുമോ?
Others.
I'm not able to identify
Testing
from
വരെ
which
കേട്ടു.
slide.
Testing.
Ma'am, testing, like the testing the features of that.
Okay, fine. Okay, the slide is visible, right?
Yes,
Yes,
ma'am.
ma'am.
Okay. So in the testing phase,
This slide.
okay. So in the testing phase, you have to extract a portion of the training data, not completely, but a portion, like 70-30 ratio, we can say like that. So a portion of the training data is extracted, and we are giving it as input to the computer program, that is the machine learning program, without the label. We are removing the label this time because we are going to check whether the computer correctly give the label as the output. So based on that output, an accuracy measure is given. So based on the accuracy, the user can determine whether we have to increase the number of epochs. That is what happens in the testing phase. So what is the goal of all this? This is all for the prediction on new data, because during the training phase, we have learned if we are considering this example, in the training phase, we have trained our computer or the machine learning program with the inputs of this image and this image. Notice the images, and based on that, the machine learning model has been developed and it was tested, and it will give you an accuracy. And in the next phase, we are giving another image. And this example says that this image is very similar to the one that is that I have displayed of the Toby, but in a different angle and different position. And but the features are really the same, right? So I am giving this image to the computer, and the computer will display inside this program. There are so many calculations, mathematical calculations, and that is why we are using mathematical algorithms. There are so many algorithms for that is so many algorithms, different algorithms, one running in this machine learning program. Based on our requirement, we can select which algorithm you want to train with, and this algorithm will output some probability values like this, that Jack 11% or Toby 89%, and this may vary. Sometimes the machine will if it is trained well, the machine will tell you Toby is 100% and Jack is 0%. So we can conclude that whether it looks like Toby or not. That is actually the goal, to predict on new data. Once you have trained with some data, sample data, then it is easy. It's easy to get the prediction on new data. So right now things are fine. You have our computer or the machine learning model is able to recognize Jack and Toby. So consider another scenario in which there is another white dog is there with the same features as that of Toby's, but you have to notice that the breed is entirely different. One is Labrador and another one is Pomeranian. But so if the computer is saying that this Pomeranian is Toby, that is entirely a fault one, and we cannot rely such a model. So what will you do at this time? That means these features are not enough. I think you can understand the matter and you will agree. These features are not enough to recognize Toby and this new Pomeranian dog as itself. So we need some more features. That is why we often say that feature selection is very important in machine learning. Depending upon the features, the selection of features determines whether we can relay the machine learning model or not. If the feature selection is not wise, or if it is weak, our machine learning model cannot be relied. It will give good accuracy, and if it will give a good result, or reliable result if the same kind of data is given. But if another data is given, the model will give you the opposite result. So we need more refined features that specifically or uniquely identify each data. For in this case, we can say that tall legs identifies Toby, and long and straight tail, short body hair, and uh, this Pomeranian has also its own features. And we have to input these characteristics in some form into the computer so that it will be able to learn this Toby and the new data. So you have to notice this point in your mind, that feature selection is something which is very important in machine learning, that determines the reliability of your model. So consider another scenario. Right now you have numerous dogs with same features, sometimes same features, sometimes different. How will you recognize all these dogs? It is another confusing thing, right? There is another situation coming up, another situation where along with the set of dogs, there are some set of cats also, which also have the same for number of legs, number of tail, number of ear size, or the shape of the face. All these are almost same. So things become more difficult, right? But I suggest you no need to worry on this part. That is why machine learning has advanced itself to the level of deep learning. So I am not sure how I am not sure whether you all are aware of the image processing in computer. Since you are students from bio background, let me introduce just an idea about how images are processed in computers. I am giving this, I have inserted this slide because image, all this data are given as images, right? So how the machine learns this image, that is the fact, that is the thing which is crucial in machine learning. So in machine learning, sorry, in computers, in case of computers, when you give an image as an input to the computer, and thus that image is read by the computer by subdividing it into small equal sized and shaped areas, and each of these areas are called pixel. This is one pixel and this one is another pixel, which are represented by numerical values depending upon the brightness of this pixel. The value will range between 0 and 255. For very dark black pixels, it is represented as 0, and for pure white, it is represented as 255. And all the other shades in between are indicated by the numbers in between them depending on the gray levels. So this is how images are processed in the numeric matrix. So in case of such a bulk of data with, say, almost similar characteristics is given as input to a machine learning model, what the machine learning will do is it will extract each of these images and will convert it into the image matrix, that is the pixel matrix. So each object will have different image matrix, that is very sure. So that is how the uh, deep learning works. So in that deep, and this image matrix serves as the feature. So in deep learning, there is no need for you to select the feature. While in machine learning, which was the traditional one, in machine learning, we have to select, we have to decide, the user has to decide what the features should be. So that was a Herculean task actually, because as the problems, as the challenges I have mentioned, feature selection determines the reliability, and we have to wisely select the features, and sometimes it happened through trial and error approaches. But in case of deep learning, when it comes to deep learning, which is a very recent advancement in machine learning, there is no need for the user to select the feature, but the algorithm itself does that. So the user has to only give the input data, the machine learning algorithm, that the algorithm may be there are different algorithms. You can determine which algorithm you want to apply depending on the purpose, and that algorithm will itself extract the features and give you the classification results. And another advantage of deep learning is that while in machine learning you will get whether it is yes or not categorical value, sometimes it is a categorical value or sometimes it is a discriminant values. While in deep learning it will give you some more details about the input data. In case of machine learning, when it gives output as car or not car, in deep learning it will give you some more details about the classified output. That is how deep learning helps us. So in short, we can summarize that in machine learning we will give some data which will be trained by particular machine learning algorithm that will that will construct a model, and when a new data is given to the model, it will predict, and depending upon the prediction result, you can check whether the algorithm should be trained again, the machine learning model should be trained again or again. And once you are fine or happy with the prediction results, you can say that a successful model is developed. That is what machine learning is. So now let's move on to the different types of machine learning. Primarily, machine learning is divided into three types, and the first one is supervised machine learning. And we were discussing so far about supervised learning, that is the learning using labeled data. We will give the data along with the labels or some annotations to recognize that data, and the machine learning model will classify it or predict it correctly. So in that case, you are getting a supervision of, that means there's a teacher, and you have to teach by the lessons, that is the label is used for learning that process. While in unsupervised learning, the next one is the unsupervised learning, the label will not be given, only some group of input data will be given, and the machine learning model will discover the unknown patterns within that data and will classify it into corresponding groups or clusters. So in unsupervised learning is mostly used for clustering or grouping task, while supervised learning is used for classification task. So that is about unsupervised learning. And the third one is another one is also there in between, that is semi-supervised learning. In semi-supervised learning, sometimes we can give us labeled data or sometimes we can give it as unlabeled data. So in under each of these categories, there are different algorithms. The SVM, which you are going to listen in the coming session, will comes under supervised learning, and the um, artificial neural network, which I am going to take tomorrow, is also comes under the supervised learning technique. So when it comes to reinforcement learning, it is the learning based on feedback. This kind of things, in this reinforcement learning, there would be an agent and an environment. These are some parameters, and the agent will perform some actions. There will be one objective. In this case, the objective is that the mouse should reach the cheese at the earliest. So the agent has to take its own decision. That means the model has to take its own decision, and based on its decision, it will initiate an action, and the action will give a feedback, or means a reward in back. And based on the reward, the agent will check whether the action was right or not. If it was right, it will proceed in the same way, and it was wrong, it will proceed in the different way. So that is about reinforcement learning, which is mostly used in case of online games. When you play some games with computers, the computer will take decisions based on the reinforcement learning algorithms running behind. So to conclude, not to conclude the entire session, to say that the use cases of machine learning, it varies from almost all sectors of life, from travel, in case of travel, the dynamic pricing or predicting the flight delay. For all this application, for all this for all these applications, machine learning programs are running behind, and in marketing field, in healthcare, which is the most beneficiary of the machine learning, I would say, then in social media, then sales, automation, credit and insurance, and in similarly in almost all sectors of our life, machine learning is playing a good role nowadays. And our aim is, or our you are here as life science students, you are here to know why you have to learn this computational techniques, right? Because in nowadays, in biology also, and in medicine also, this machine learning are playing wonders. And this is a recent update that I got from that the work is published in the Annals of Oncology Journal in this year itself. And it says that a new blood test can detect the 50 types of cancer, and they have used one machine learning technique to make this achievement. And the input data which was given to this cell-free DNA are actually that. So these are given as the input to the machine learning model, and the machine learning model could detect dangerous cancer types that lack effective standard screening approaches. And it was also able to locate the cancer cells also. So this is one application that I found as interesting. And in cancer diagnosis and cancer treatment, machine learning and artificial intelligence are playing a very good role. And sometimes it is exceeding the talent of doctors also, even though that is not promising, because we cannot, critics says that we cannot relay a computational model to proceed with the treatment and diagnosis. So of course that's true, but it enables you to cut down it will ease your task. So in various kinds of cancer detection, machine learning approaches are used nowadays, and also in other health issues, like machine learning helps scientists to measure the important inflammation process, and in terms like artificial neural network or SVM, or sometimes a mix of both, or both or many this kinds of that decision trees, some ensemble methods. Ensemble method means it's a group of machine learning algorithm. So either one algorithm or multiple algorithms will play a role in all these things. So the thing, what you have to keep in your mind is the algorithm is the same. The what differs is the data that you're giving and the output you are obtaining. So whatever data you are giving, that you will get some and results which will, and the analysis of those results will give you some valid insights in whichever field you are. Some other headlines in news reports I have pasted it there, and if you are interested you can just google with these headlines. You will understand how they have proceeded to attain all this uh, advance. And in coming to bioinformatics, you know that nowadays the quantum of data is increasing due to the advancement of ingest technologies and all. And this analysis of this increasing amount of data demands the development of machine learning systems for bioinformatics applications. So machine learning is perhaps most useful for the interpretation of large genomic data sets and has been used to annotate a wide variety of genomic sequence elements. So in gene finding, for example, machine learning machine learning methods have been developed to determine the location of protein encoding genes within a given DNA sequence, which will give you annotated GNA. There are improvements on one particular if you have developed one gene finding algorithm, if you find one gene finding algorithm in one literature using machine learning method, you may see several improvements over that particular method itself. So it's up to you to determine which method you have to use, and how you can best take such a decision is based on the accuracy and the results that is obtained. So it is also enables you to identify the transcription start sites, splice sites, promoters, enhancers, and also to recognize the signals generated from regulatory sites in genome sequences. And in all these scenarios, machine learning is giving us good results. So in general, if one can compute a list of sequence elements of a given type, then a machine learning method can probably be trained to recognize all these elements. Then gene expression, not only the sequence data, but the gene expression data is also used to distinguish between different disease phenotypes and also to identify potentially valuable disease biomarkers. And in coming to proteomics, machine learning methods have been applied to predict protein secondary structure, protein side chain prediction, protein loop modeling, and all. And in systems biology or synthetic biology, which are some other disciplines that come under computational biology and bioinformatics, in that systems biology actually deals with the interactions of cellular components and mathematically modeling those components, those interactions. So in systems biology also, machine learning methods are applied for modeling the interactions. And in synthetic biology also, here is one such work where the scientists were able to predict channel rhodopsin, which is a integral membrane protein, and they were able to engineer it by studying the association between its structure and function using machine learning methods. And CAD, computer-aided drug design, it is a very very promising methods. Drug candidate identification via molecular docking was able to attain using machine learning methods, and it was helpful to predict and pre-select interesting drug target candidate interactions. As you know, in computer drug design, from target identification and validation up to the clinical development, machine learning is applied in almost all stages and gave successful results. So, and to the last in the list is the COVID-19 studies. And deep learning is used in various apps. Deep learning is the technique that is trending now. Nowadays, we won't go behind machine learning. It is like whether to use a smartphone or an ordinary phone nowadays. So deep learning is also used for, in this paper, used for COVID-19 studies also. In this paper, which is published in May 2020, they says that they have used deep learning method to increase the accuracy of the detection or determine the accuracy of the detection diagnosis results of COVID-19 test. It improved the accuracy of the reported cases and precisely predict the disease by giving the chest X-ray images, so that they can determine whether there are false negatives in their results. And also the prediction of novel drugs for this SARS-CoV-2 virus, and also for the drug repurposing. In all these things, machine learning and artificial intelligence are also used. And apart from these applications, deep learning is used to predict the extent of the spread of the COVID-19 disease nowadays, considering all the different aspects. So we can say that considering the heterogeneous data, they are able to predict the extent of the spread in future also. You may notice that in October, now you may notice news report saying that in November it will be in a peak, or it will be down. The spread will be gradually coming down, or these kinds of things are there. For these things, just statistical measures are required. But for when you consider more factors and more features, you need deep learning. So in short, machine learning and its advanced version, deep learning, are making valid contributions to the biological and medical field that help all of us, each one of us, to better our life. So that's for the time being. Thank you.
Thank you so much, ma'am. That was really a wonderful session for us.
Okay.
Participants, you can ask your doubts and queries in the
Okay,
chat
thank you.
box. So we have the first question, ma'am, that is from Adarsh. What will be the
Okay.
best algorithms that can be used when coming to DNA and predicting different features based on the sequence patterns and characteristics?
Okay, Adarsh, in my slide, I have explained about image data, right? So when coming to sequence data, there are various factors. We have to, sequence is actually text, right? So it is a text data. So when coming to machine learning, we have to convert this sequence to some form of mathematics. We have to transform it mathematically so that computer is able to read it. So different mathematical transformation methods are there for converting, doing this transformation, and that's how sequence patterns are actually read by the computer. And when it is
Hello, ma'am.
apart from the sequence data, if it is the entropy, these kinds of mathematical algorithm nowadays, as the deep learning has
You were mute for some time that we couldn't hear you what you were saying.
Hello, am I audible now?
Yeah, but we couldn't hear you what you were speaking sometime earlier. That's the
Yes, ma'am. You
problem.
kind of
Okay,
dropped out.
let me continue. You were not able to hear anything?
Yeah, we
Or
heard till like we need to
okay,
convert the text
okay, fine.
data.
I shall continue. Okay, when it comes to sequence, with the emergence of deep learning, we have specifically designed algorithms for handling sequence data, and one among them is the recurrent neural network, which is the most trending to handle sequence data. Otherwise, we can use traditional methods like artificial neural network is also used. Then genetic algorithms are used. Then some ensemble methods, which are a combination of different algorithms, are also used. But since it is deep learning, which is trending now, it has specific algorithm for handling sequence data, and one among them is the recurrent neural network, which is most popular one now.
Okay, ma'am. I was the one who asked that question. I'm Adarsh. I have one more doubt.
Okay.
Like,
Okay.
can we do a deep learning like study using our normal kind of laptop? Do we need to access
It's
like
no.
Google Cloud or something like that kind of services for doing this kind of thing?
Actually, for doing deep learning is actually designed for GPU computers, but because in GPU is designed for handling huge amount of input data, not only or 50 to 60 sample images or samples. It is defined for gigabytes of data. So for deep learning, it is better if you have a server connection, but you can also try deep learning or learn deep learning with one or two not one or two, just 20 to 25 input samples also. But for doing that perfect, for running the deep learning program perfectly well, you need a server connection. That is the best thing. The other one will also give you the result, but it will delay, or some other technical issues will come in between. You can run sample deep learning programs in your laptop, that is fine, but the best thing is to use a server connection.
Okay, ma'am. Thank you. Thank you
And
so much.
also recently, deep learning programs have been in the earlier it was designed for GPU only, but nowadays I think CPU enabled GPU packages are also available. So you can try it in your laptop, but if you wish to get the real benefit of deep learning, you have to try using a server. That will be the best.
Okay, ma'am. Thank you.
Thank you, ma'am. We also
Okay.
have one another question, that is, how can we relate machine learning with network analysis?
You mean how to apply? Is that apply in
Yes,
network
ma'am. It's,
analysis?
I don't know who asked the question. It's like, yes, ma'am.
Okay.
I think the person meant that.
Okay. Okay. In network analysis, the graph images are majorly used. When applying machine learning, you have to identify the patterns or the kind of interactions within the graphs. So for that, you have to input in the training session. You have to give the input as already known network interactions, and that is given as the input, so that the algorithm will be able to identify the patterns of interactions, and that will give you the output on your desired input. I hope it is clear.
Thank
Okay.
you so much, ma'am. Yes, ma'am. I don't think there are any more questions. Nobody has asked. So that's it. Thank you, ma'am.
Okay.
Thank you so much for taking your time out to give us such an amazing session.
Okay, fine. Thank you all.
Thank you,
I'm
ma'am.
also happy that you could benefit it, if you could benefit it. Okay,
Yes,
fine.
ma'am. Definitely, ma'am. Thank you. So we'll continue with our next session by 11:30. So participants may leave the Zoom meeting and may join back at 11:30. We'll have the second session. Thank you all.